Welcome back, Algebra 2. We're in lesson 128. I'm going to talk a little bit about circumscribed and inscribed. If something is circumscribed, it means it is around or written around something else. The word circumscribed comes from the Latin word circum, which means to be around, also circus, so we have the round rings, and scribere, which means to write. So something that is circumscribed is drawn around. So that's literally what that word means, to draw. Let me get a little bit thicker line here. To draw around. And that's a little bit too thick. Let me adjust that. That's a little bit better. Inscribed is literally what you would think it would be. It's written inside. So it's inscribed. So to draw inside. That's what that means. And if you look here at this illustration, we see that the circle is circumscribed around the triangle, and the triangle is inscribed inside the circle. Okay? Now, speaking of circles and triangles, inscribed and circumscribed, here I have a triangle, and one of the cool features about a triangle is that if you draw a line, let me get this thicker green line. If you draw a line from each angle, bisecting that angle to where it's perpendicular to the bottom or to the base across from the opposite of the angle, if you do that, I'll show you here, then what happens is you get a center point that makes all of these lines here congruent, and then all of these lines congruent. And then the point in the center in which they cross, you can inscribe a circle around. The shorter lines that are all congruent become the radius of this circle, and the circle is the locus for the central point here of all of these lines. These are called concurrent lines, and the point that they form creates this, it's the center point of the triangle, and everything around it is equidistant relative to one another. So the shorter lines, the bottom halves, all the bottom halves are congruent, and all the top halves are congruent. And if you take the bottom half of, or the bottom portion of the concurrent line, that's the radius of the new circle that can be inscribed inside the triangle. It's all kind of cool when you look at it like that. All right, so moving on, we're going to talk about inscribed angles. So let me clear this, and I'm going to draw us a circle right here. Boom. So we're going to prove that the measure of an angle inscribed in a circle equals half the measure of the intercepted arc. And we learned all of this way back in lesson 11, but we're going to review some parts as a proof. So here I have case 1. There is the diameter, and I am going to draw another line to create an angle. And this is going to be point A, this is point B, this is point C. And we have let me erase this and this and write them on the outside a little bit so that I have more room to illustrate. From this point around to this point is the degree of measure of the arc that is to the center, or the angle that's to the center from this point to here. So the degree measure here is the degree of measure on the outside. So if this were, 50 degrees, then this would be 50 degrees. But we also know that because it is half, this one should be 25 degrees. That's what C should equal. So we are going to put that over here to the side and just hold it. Right? We're going to just hold it as a proof for now. So the first step was to draw the radius AO, and then we drew our second line here from A to the center of the circle. And what that did was that created, let me erase this for us, that created, we have an angle 1 here, angle 2, angle 3, and angle 4. All right. Arc AB is defined to have the same measure as its central angle 2. So the measure of arc AB is going to be equal to the measure of angle 2. We know this to be true. Angle 2 is an exterior angle of triangle OCA. So this is point O. Sorry, I meant to label that earlier. So that means that 3 and 2 added together is going to be 180 degrees. So what that also means is that 1 and 4, all right, let's keep track of this. Let me write it down. Because angle 2 and angle 3 are next to each other on this straight line, angle 2 plus angle 3 should equal 180 degrees. But we also know that the interior measure of a triangle is going to be 180 degrees. So what that means is that the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4 is going to equal the same thing that 2 and 3 add up to equal. If I subtract the measure of angle 3 from both sides, that cancels. So I'm left with the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 4. Now that in and of itself does not mean that these two are the same value, but we know from the center of the circle to its circumference, those are radius. And because they are radius, they're congruent. And we know that in an isosceles triangle, when you have two sides the same, that the corresponding angles are going to have the same measure. So therefore, these are going to be the remainder of the 180 minus this divided by 2. So therefore, the measure of angle 2, half of that is going to be equal to the measure of angle 1 or the measure of angle 4, right? So that tells us that the measure of angle 4 is half of the measure of angle 2, which proves that the inscribed angle here is half the measure of the arc on the outside, because the degree of measure here is the same as the degree of measure to the center of the circle. All right, I hope you were able to follow that around, that thought process. But we could say that once we divide it by 2, that the measure of angle 4 was equal to angle 2 divided by 2. All right, that's all we have for lesson 128. I will see you in our final lesson, lesson 129.